Let's do our warm-up. Pretend you walked into the classroom and I said hello and we're all there, and then you do the warm-up right away. Okay, and now I'll go over it. So air is being pumped into a spherical balloon at a rate of 800 cubic centimeters per minute. How fast is the radius changing at the instant the radius is 30? So as far as an equation, so air is being pumped into something, so that's volume. And it's also cubic centimeters, and cubic units is volume. So the volume of a sphere is 4/3 pi r cubed. We can draw a picture. I kind of skipped it, but there's our sphere. There's our radius. And it's a balloon, so its volume is changing. So if volume is equal to that equation, differentiate dv dt. 4/3 pi is just a constant, so if we take our 3 and multiply by 4/3 pi, we end up with 4 pi r squared dr dt. Okay, now what do we know? How fast is the radius changing at the instant the radius is 30? So I know the radius is 30, so that's 30 squared. I don't know dr dt, that's what I'm trying to find. 4 pi can stay. Rate of change of the volume is is the rate at which air is being pumped into the balloon. So that's 800 cubic centimeters per minute. So dv dt is 800. So we end up with 800 equals 4 pi times 30 squared, which is 4 pi times 900, which is 3600 pi dr dt. We divide by 3600 pi on both sides. So dr dt equals 800 over 3600 pi. Make sure if you put this in the calculator, you put parentheses here, otherwise it'll take the numbers divided by each other and then multiply that fraction by pi. And if you put this in your calculator properly, you should get 0.0707 centimeters, because a radius is just regular centimeters, not cubic, not square units or anything like that. So 0.0707 centimeters per minute.